We've discussed reactions with organometallic reagents. Here let's talk about how these organometallic reagents are prepared. They can be formed by adding lithium or magnesium to an organic halide, so an organic carbon chain bonded to a halogen. So let's say we'll do isopropyl bromide. These preparations must be in an aprotic solvent. So this example formation of an organometallic reagent was done in pentane solvent. So we have isopropyl bromide and we add lithium and we'd add it as a metal. So we have pentane solvent, some isopropyl bromide added, and then solid lithium metal added to that pentane solution as well. In that solution now, the lithium metal will react with the isopropyl bromide, and you'd form the organometallic reagent where now that carbon is bonded to a lithium. And then you also have lithium bromide LiBr ions as well. So this is isopropyl lithium. We can draw these as skeletal structures. So isopropyl bromide looks like this. Isopropyl lithium looks like this. Now the bond between carbon and lithium, we're representing it as a covalent bond, but it has a lot of ionic character. So it's a blend of covalent and ionic bonds. We can talk about bonds as having covalent character or ionic character. This has more ionic character, which is why it's useful in these reactions, because that carbon that's bonded to the lithium is owning most of the electron density between carbon and lithium is owning very little. And so the lithium can leave as a cation, and that carbon bonded to the lithium would obtain the electrons in that bond. So here's one example of forming an organolithium. We'll do another example. So here, example 1, example 2. Bromobenzene. Again, with lithium metal. This preparation can be done in diethyl ether, and we would then form phenolithium. And again, lithium bromide. So both of these examples, we are taking an organic halide, an organic chain bonded to a halogen, adding lithium metal in a aprotic solvent. And we form the organic halide, or the organolithium reagent. Grignard reagents are prepared similarly. We start, Here's another example 3. We start with an organic halide. Here's an example. We'll have a phenyl ring, 2 carbon chain, and then a bromine. To form the Grignard reagent, we need magnesium. And then again, we use a aprotic solvent. So here's diethyl ether. With these reagents, we form the Grignard reagent, where now the magnesium is bonded to the carbon that was bonded to the bromine, and then magnesium is also bonded to a bromine. Now let's do one example where we will generate the organometallic product. We'll add an aldehyde or ketone reagent, and we'll go through how to get our final product. So all 3 of these examples, we've started with a bromine as a halogen. It could also be chlorine. So here's an example reaction to get our final product. So we'll start with chlorobenzene. We're adding lithium and THF, tetrahydrofuran. That is a ether solvent. And let's put in some boxes. So let's say we're given some information and we're going to try and fill in these boxes after we've put everything together. So we have a box here we'll need to fill in. After this step, so this is like one of the questions we'd have in class or on an assessment, where you have a multi-step reaction. You're given enough information to draw intermediates or add reagents as needed, but you're not given, of course, all of the information. And so we'll work through this after we write all of the steps. And this is the last one here. Okay, so here's our 3-step reaction, and we're assuming that you're given all of the information that's here now, and then we're working through the problem. So we're starting with an alkyl chloride, an organochloride, an organohalide. We're adding lithium in a polar aprotic solvent, and so this will result in the lithium replacing the chlorine. And we generate an organometallic reagent. Organophenyl ring bonded to metallic lithium. Byproduct here is lithium chloride. Now we have an organometallic reagent in the presence of an aldehyde. So when we have an organometallic reagent, that carbon, the organic part of that reagent, will add to the carbonyl carbon in the aldehyde in this case. So that aldehyde or ketone in other cases. So I'm going to start by copying the aldehyde molecule. So we've got carbon. That carbon to oxygen double bond will break. We're still carbon still bonded to a hydrogen, and then now we have another phenyl ring bonded to that carbonyl carbon. At this point, there's nothing in solution to protonate that carbonyl oxygen, so it still has a negative charge at this intermediate step. In the next step, we add H3O+, we're adding an acid, and so that will protonate that oxygen, and we get our final product. We have the alcohol bonded to what was the carbonyl carbon. We still have that aldehyde hydrogen present. Let's do another practice question here. And let's say we are, okay, so let's say we're going to write out the reagents. So we'll know that the solvent is an ether, and then in step 2 we add an acid. And this is the final product. Some alcohol product. And so the question is, what reagents? We'll do specifically Grignard reagent. So we're looking for a Grignard reagent and then an aldehyde or ketone to produce this alcohol product. You could pause the video here and try completing this on your own. I'll of course go through it. One thing I noticed immediately looking at the product is the location of the alcohol group. The alcohol group, when we're adding Grignard reagents or any organometallic reagents, the alcohol oxygen comes from the carbonyl oxygen. So that means in the starting material, we have a carbonyl at that location. And there are actually two combinations of Grignard reagent and an aldehyde or ketone to produce that product. Let's do the first one here. So we could say that carbonyl oxygen was bonded to a carbon, which is bonded to a CH2, which is bonded to a phenyl ring. Well, if that's the case, we, in the Grignard reaction, are adding a carbon chain so that hydrogen right here that's bonded to what I know is the carbonyl carbon based off where the alcohol group is. This indicates that the starting material was an aldehyde because we are not adding any hydrogens to the carbonyl carbon or what would have originated as the carbonyl carbon. So we know we're starting with an aldehyde. This could be one starting material. And if that's the case, this is the aldehyde starting material, then the carbon chain that's getting added is this ethyl group right there. So then we must have an ethyl group bonded to a magnesium bromide to generate that final product. Now, I said there were two different combinations of organic reagents and organometallic reagents that could produce this final product. This first set of reagents would certainly produce that final product. The second set would be if we then have our carbonyl at the same location. It has to be where that alcohol group is the carbonyl carbonyl oxygen. But we could also say that the ethyl group was part of the original aldehyde. So if that's our original aldehyde, then the organic part of the organometallic reagent that's added would be the phenyl ring with that CH2 group. So this whole reagent here. could then be added to the carbonyl carbon, and we'd get the same final product. So our first set of reagents would produce that final product, and our second set of reagents would also produce that final product. So often, if you're given the product of a Grignard reagent reaction or the addition of an organolithium to a carbonyl, then the starting materials are really two different options of what aldehyde or ketone and organometallic reagent that could be used to create that final product.